So, for this video, we're going to look at a couple of rates of change based questions. The first one says, given the area of a circle of a centimetres squared is related to its radius by a is equal to pi r squared, which you should be more than familiar with, and that the rate of change of its radius in centimetres per second is given by dr by dt is equal to 5, find dA by dt when r is equal to 3. So we'll deal with this one first. Now, the clue with rates of change questions is you're basically going to use the chain rule. So let's start with what they're actually after us finding. They want us to find something for dA by dt. Well, we don't have enough information to jump straight to that. So let's have a look at what we do have. Well, we do have A in terms of r, so we can differentiate this, and we can work out dA by dr as an expression. And that's fine, but obviously this is not equal to this. We want a dt in the denominator, not a dr. Well, we're also given a value for dr by dt. And fortunately, in this question, we can multiply the dA by dr by the dr by dt, such that the dr's cancel, which leaves us with dA by dt, which is what we want to find. So in order to use this then, we're going to need an expression for dA by dr. Now, because a is equal to pi r squared, it's a simple enough differentiation. Bring the power to the front, 2 pi, drop the power by 1, so you're left with 2 pi r. So we have 2 pi r for our dA by dr times our dr by dt, which is 5, or in other words, we have 10 pi r. And that would be an expression for dA by dt, but we don't want an expression because we're given a value for r is equal to 3, so all we need to do is substitute that in. So when r is equal to 3, that implies that dA by dt is equal to 10 pi times 3, which is 30 pi. So then we've got a slightly more complicated problem at the bottom. The volume of a hemisphere of v centimetres cubed is related to its radius r centimetres by the formula v equals 2 over 3 pi r cubed, and the total surface area s centimetres squared is given by s is equal to 3 pi r squared. Given the rate of increase of the volume in centimetres cubed per second, dV by dt is equal to 6, find the rate of increase of the surface area, dx by dt. So we've got a little bit more to do on this, but it's a similar process. So let's start off with ds by dt, because that's what we want to find. So in the numerator, we want a ds, so let's put that first. Let's look at our s expression. Well, it's in terms of r, so just like the last one, all we can do to start with is find ds by dr. Well, we don't like the dr, so we need to look for another expression with r in it, and all that we've got is v, the volume in terms of r, so we're going to use that one. We want to get rid of the dr, so we're going to have the dr in the numerator, and because v is the other variable there, over dv. And again, we still don't want this dv in the denominator, but fortunately we are given a value for dv by dt, so we can use this one, dv in the numerator, to get rid of that dv over dt. And if we see here, the dr's cancel, the dv's cancel, which leaves us with ds by dt, which is what we can use. So we have a value for dv by dt. We need to generate expressions for ds by dr and dv by dr first to then make dr by dv. So let's start with ds by dr. So as s is equal to 3 pi r squared, ds by dr, bring the power to the front, is 6 pi r. As the volume is equal to 2 over 3 pi r cubed, we can say that dv by dr, bring the power to the front, is 2 pi r, drop the power by 1 squared. And all we need to do now is substitute in our different parts. So dx by dr, 6 pi r. dr by dv becomes 1 over this. So 1 over 2 pi r squared times dv by dt, which is equal to 6. And then we just need to simplify. So the pi's are going to cancel. You have 6 times 6, which is 36, divided by 2, which gets you 18 in the numerator. That r is going to cancel with one of those r's, so you get 18 over r. So therefore, dx by dt is equal to 18 over r. Now note, for this one, we are left with an expression at the end rather than a value, because we're not given a value of r to substitute in, whereas in this problem we were given a value.